What you're seeing here is one of the sample projects that comes with Revit running in real time. To start, I'm going to work from the RCP for Level 2. System Designer will work either from a floor plan or RCP. From the BIM Acoustics tab, I launch the System Designer. The first thing the add-in does is scan the project and build a room list. By default, it filters out spaces that usually don't need coverage, like closets and support rooms, but you can include everything if you want and then choose exactly what you need. Once I've selected the rooms I want, the tool immediately reports key room data, area, surface area, and room volume, and it detects ceiling conditions. If there's a ceiling in the room, it identifies the ceiling height and the ceiling type. If a room has multiple ceiling conditions, it flags that in the ceiling notes so you know to review it. Next, the tool makes initial design assumptions based on best practices and typical room use. It assigns a spacing mode like minimum overlap for speech-critical rooms and edge-to-edge for corridors, and you can change any room to whatever spacing rule you want to use. For hosting, you can either use the detected ceiling, or you can choose to place loudspeakers on a reference work plane if that's your preferred workflow. Using a work plane can be useful if ceilings change later and you don't want to lose your devices. In this demo, I'm using the ceiling host. It also sets listener height assumptions based on room type, seated versus standing, and you can override those values anytime. Then I select the loudspeaker model I want to use. I can choose a default loudspeaker and apply it across the entire selection. And if I want, I can override specific areas like corridors or restrooms with a different model. When the family includes coverage data, the tool picks up the coverage pattern from the family automatically, if it exists. After that, I refresh the calculations. Now the tool updates the spacing calculation based on the actual coverage pattern. It also applies target SPL assumptions by room type, and you can adjust those targets if you want. If the family includes transformer tap parameters, the tool can evaluate the available taps and pre-select the tap that best meets the target. Now I go to Preview. This is a summary of the selections I've made: spacing mode, layout settings, loudspeaker choice, targets, so I can confirm everything before I place anything. For real-time proof, I switch back to the active RCP view and commit placement. This is where you see how fast it is, and the system places loudspeakers across all of the selected rooms. After placement, the tool reports any rooms it skipped or flagged for review, typically because of ceiling condition or hosting condition that needs a second look. Those are the rooms where you may want to verify the ceiling choice or adjust placement manually. At this point, I can also show that these are real Revit elements hosted by the ceiling, and I can inspect the parameters that were set during placement: ceiling height, listener height, spacing mode, and other design inputs, so it's clear what assumptions were used and what the tool actually did. These circles that you see around my loudspeakers are actually spacing circles that I added to my families. Now that the speakers are placed, I can review each room, nudge the speakers into the center of the tiles, then go to the Results tab and compute the results. This shows me what was placed, the rooms involved, the target SPLs, and then the actual predicted outcome. For example, it reports the minimum SPL in each room, the maximum SPL directly under each loudspeaker, and it summarizes how much of that room falls within different performance bands, like plus or minus 1, plus or minus 2, plus or minus 3 dB, and how much falls outside of that window. I can generate isoline coverage mapping to visualize it. I draw the ISO map and it gives me a clear picture of coverage levels across the space, so I can spot weak areas quickly. If a room shows weak coverage or an uneven distribution, I can immediately go back, adjust the loudspeaker locations, add or remove any loudspeakers where needed, refresh, then recompute results, and see how the coverage changes without rebuilding the entire layout from scratch. Once I'm happy with placement and results, I go to the next floor and run it again. That's the workflow. Pick your rooms, accept or adjust best practice defaults, choose loudspeaker models, preview, commit, placement, review results, iterate if needed, and generate isoline mapping to visualize coverage. The add-in also creates a schedule listing all of the loudspeakers placed by the add-in. This allows you to run the add-in again at later stages of the design process, when walls are moved, ceilings are moved or changed, and the add-in knows what was placed before. It will remove any previously placed loudspeakers and place the new ones at the new spacing. You probably noticed over here on the side the Lucius AI. It's not a chatbot and it's not generating designs on its own. Lucius is there to support the designer while they work. Lucius is aware of the current Revit context. It knows what view is active, whether you're in a plan, an RCP, or a schedule, and it can read information directly from the model. When you ask a question, Lucius uses that live Revit context along with knowledge about acoustics, AV system design, and the BIM Acoustics tool to give relevant answers. That means you can ask things like why a room was flagged, what a result means, or what a particular setting does, and get an explanation that's specific to what you're looking at, not a generic response. Lucius also explains design assumptions. For example, it can describe why a certain spacing mode was chosen, what listener height is being used, or how target SPL values affect coverage results, and how changes to spacing, loudspeaker choice, or targets will affect coverage. Now, Lucius doesn't replace engineering judgment. It doesn't automatically make design decisions, and it doesn't change the model without the designer's intent. Instead, it acts more like an experienced colleague sitting next to you. helping explain what the tools are doing and why certain outcomes occur. The goal of Lucius is to reduce friction, shorten the learning curve, and make advanced workflows more accessible without taking control away from the designer. It's there when you need it, and it stays out of the way when you don't. If you want more detail, more examples, or to try it for yourself, you can find more information at bimacoustics.net. Thanks for watching.